Alright, another unit for you guys. We're going to talk about some lovely this stuff, okay? I got some really cool pictures in this lesson here for you guys. I don't know why, I don't know what it is, but photographing water is probably one of the coolest things ever. So, if you couldn't guess, that's what we're going to talk about, Earth's water. Yes, you gotta just love learning about our lovely Earth. That's pretty much been the last 4 units, okay? So the first 4 units are pretty much all about our planet Earth, which is fairly fascinating if you ask me. Okay, there's a lot of cool things going on our Earth. This particular unit is on water. Yes, so water, water, and more water, okay? By the way, just look at these pictures. Look at this one. Don't you wish that you were sitting on the beach looking at that right now, especially after our blizzard? So anyways, depending on when you're watching this, maybe this is a different time, but yeah, we just had a blizzard here. But it wasn't really a blizzard, so I wish I was sitting on the beach looking at this lovely ocean here. Alright, so let's talk about water and the Earth's water. We call it the hydrosphere, and people are like, what? Like anytime you see like sphere and like biosphere, hydrosphere, well, the Earth encompasses lots of different spheres, so to say. Okay, when we talk about the hydrosphere, we are talking about the water within our Earth, okay? It's basically what goes on in the water. I mean, just everything that encompasses the water. So that's the hydrosphere, is dealing with the water on Earth. So if you hear that term thrown around, now you know what it means. Hydro, water, sphere, yes, sphere, you know what sphere is. Okay, so moving on, just some fun facts about water. So we obviously need it for survival. Most of you guys have heard this before. You can survive anywhere from maybe 3 to 7, maybe 10 days max without water. Depending on, say you had a bunch of water and then all of a sudden you were deprived. So maybe you'd be able to last a little bit longer than if you were kind of not drinking a ton of water to begin with, and then all of a sudden your water supply was cut off. Water's absolutely needed. Our bodies are pretty much 97% water, just like this Earth. Isn't that kind of interesting? Okay? Down here you'll see 97% of the Earth's water is found in oceans, but really I shouldn't say the Earth is not 97% water, but it seems like that. When you look at the Earth from a distance, you see these continents that make up pretty much, nothing of our Earth. But nonetheless, our bodies are the same way. Every cell is made up of pretty much all water. So if we deprive our bodies of water, we're depriving our cells, which are the basic unit of structure and function in our bodies, okay? So our cells are really important. We need that water for it. It's for survival. Okay, water also comes in 3 forms, the states of matter: solid, liquid, and gas. We know, the solid form being ice, the liquid form being the water that we drink, and the gas form is, water vapor or steam, okay, that we sometimes see. So that's kind of not really interesting, but just, one of the little tidbits of water. And then down here, 97% of the Earth's water is found in the oceans. Okay, so interesting that, we need water for survival, yet 97% of it is not water that we can drink or consume, okay? So the remaining 3% is fresh water found in glaciers, groundwater, and surface water. And actually, even in glaciers and groundwater, we're not able to really easily access that for our consumption. So surface water makes up just a small portion of that 3%. Yet it's vital for us to live. So it's interesting that even if you think about when after the winter time, if we haven't had a robust winter where we get tons of snow, then we're on water restrictions usually in the summer. So we cannot we can't conserve, or we can't consume too much of our water, because obviously it's got to sustain us. So anyways, I could go on about that forever, but nonetheless, here's just some facts. So how about some visuals? You know how he loves visuals. So let's watch this quick video clip on some of the visuals of our lovely Earth and the water that is within it.
This is Big Idea 5. Earth is the water planet. Water is found everywhere on Earth, from the heights of the atmosphere to the depths of the mantle. Earth's first surface water came from 2 sources. One source was water vapor escaping from Earth's interior. The second was from ice falling to Earth from space. Water vapor in the atmosphere condensed and rained onto Earth's surface as the planet cooled. Water is essential for life on Earth. Water has simultaneously existed in 3 phases on Earth for billions of years. These phases, solid, liquid, and gas, allowed life to develop and continuously evolve over time. Water's unique combination of physical and chemical properties is essential to the dynamics of all of Earth's systems. Its special properties include the way in which it absorbs and releases heat, how water reflects sunlight and expands on freezing, and its ability to dissolve many other materials. Water plays an important role in many of Earth's deep internal processes. It allows rock to melt more easily. This results in much of the magma that erupts from volcanoes as lava. Water helps metamorphic rocks to form. It is also vital to plate tectonic processes. Earth's water cycles among the reservoirs of the atmosphere, streams, lakes, ocean, glaciers, groundwater, and deep interior of the planet. The total amount of Earth's surface water has stayed fairly constant over geologic time. However, this water has been located in different reservoirs at various times. Water shapes landscapes. Flowing water in streams strongly shapes the land surface. This happens through weathering and erosion, as well as through transport and deposition of material. Water both dissolves some earth materials and forms new ones. Ice is an especially powerful agent of weathering and erosion. Water expands as it freezes. This process widens cracks and breaks rocks apart. As huge glaciers move, they scour away the surface of the land. During ice ages, glacial ice flows covered and changed great portions of the continents. Fresh water is less than 3% of the water at Earth's surface. Most of this fresh water is stored as glaciers in Antarctica and Greenland. Less than 1% of Earth's near-surface water is drinkable, liquid, fresh water. And 99% of this water is groundwater in the pores and fractures within soil, sediment, and rock. And that's Big Idea 5. Earth is the water planet.
So, kind of a cool video that describes a little bit about, well, not a little bit, I thought a lot, about what Earth needs this water for, what purpose it plays, how vital it is, and all the things that it does. So, anyways, there's some lovely visuals for you. So let's talk quickly about the water cycle, because this is something that is a pretty easy cycle to envision because we see it often, right? Let's start up in the clouds. Well, basically we have condensation of water molecules, water vapor, okay? And as those condense, we start to see clouds. Why we see clouds is because there are so many water molecules that we can start to see them. Well, what happens is over time, those water molecules become more and more dense, and all of a sudden they're too heavy to remain up in the air, so they fall down as precipitation, okay? So precipitation falls down in different forms, which we'll talk about in a moment, but you have precipitation, and then it becomes surface runoff, which can run into lakes, rivers, streams, you name it, okay? And this type of surface water, some of it stays and remains on the surface, and other parts of that water kind of seep into the ground and becomes part of the groundwater or the water table, okay, that exists underground. Okay, some of that surface runoff also runs into the ocean, and both the ocean and the lake is where you have evaporation. So depending on the air temperature, but also many different factors, but evaporation is constantly occurring. And by the way, there is a part in your lesson that you can read that what causes more evaporation, okay? But evaporation is where those water molecules will then basically be taken up into the lovely atmosphere, and you see this cycle happen over and over again, okay? It's continually happening. It doesn't start or stop anywhere. It just continues to happen, okay? And it happens with, like I said, different kind of however the atmosphere and the environment depends on how the water cycle will react and how quickly it goes through it and when it happens and all that good stuff, okay? So it kind of just depends on the factors within that particular environment when the water cycle takes place and how frequently, how quickly, and all that stuff, okay? Water cycle. All right, now I just want to touch on, in this part, we've talked a little bit about water, but it's interesting, some of the human impacts that we have on water. Not so good, okay? Sometimes I think we're just not so good because we just don't take care of things the way we should. So population explosion is something that's mentioned in your unit, that basically because of this huge population that we are, contributing to on a daily matter, that basically now there's more need for water, and we still don't, it's not like our water source has become greater with our population. Our population has grown, our water has stayed the same. So now we're kind of in competition for water, okay? Not a good thing. Agriculture is one of the things that uses up the most water. It's obviously necessary. I mean, we need agriculture for growing, stuff that we eat and all that stuff, but it uses up so much water, so that can become a concern, especially with our population growth that we just talked about. All right, pollution. Isn't this a horrible picture? But we contribute to this greatly. Depending on what we put on the ground and that seeps through into the groundwater, ways that we contaminate it through our trash, through just different chemicals that we use, through our jobs. Some of our jobs have chemical waste, and this ends up in our water source pretty much all the time because our water source, is underground. It's everywhere kind of around us, that basically how we contribute in our daily just our daily lives, we are contributing to water pollution, which we need to drink that, okay? I don't know if any of us want to drink that. Gross. That's why we have these little lovely water treatment plants that use such harsh chemicals to treat water, which again I read an article about today, that most of the treatment plants are using these horrendous chemicals that are going to lead to cancer. Awesome! Just another thing to give us cancer, right? Okay. Anyways, urbanization. Another thing is, obviously we are taking over, we're building so much, we're urbanizing so much of our earth that basically we are destroying some of our water sources, and we're also contaminating some of them. So again, overpopulation, overbuilding, all those things contribute negatively to our water source that we desperately need. So, all right, moving on to a couple more things and we'll be done. Clouds. I love clouds. How many of you guys have ever just in the summertime laid on the grass and you look at the clouds go by, and some of them are moving really fast, some of them are really pretty and fluffy, and you can see different animals in them and whatever. But nonetheless, clouds can tell you a lot about the weather. So take note of these, but you've got different clouds based on where they are in kind of the atmosphere, okay? So low clouds, you're going to see stratus clouds. Stratus clouds are typically the clouds that kind of cover the sky, and they can be white or gray, but you usually see a little bit of precipitation from stratus clouds. If stratus clouds kind of come closer to the earth, that's known as fog, okay? So not always is there going to be precipitation, but stratus clouds are very low clouds. You also have stratocumulus clouds. Cumulus clouds are the ones that are kind of puffy, but these are very patchy. These are very small, little puffy clouds. So these stratocumulus clouds usually don't do much, okay? They don't build and build and build and become what we know as the cumulonimbus, okay? So let me kind of quick jump over here since I've mentioned. You have a cumulus cloud here that can grow, and a cumulonimbus cloud, these grow with vertical development, okay? So they're not necessarily just growing outwards, they're typically growing very, very, very high, and they reach the stratosphere here, and they kind of level off, and this is what's called an anvil, and you'll see these a lot in the summertime. And so you'll know that this is a big thundercloud. Okay, you have a lot of weather developing in here, lots of precipitation. Lightning can come from here, and even tornadoes can come from your cumulonimbus clouds. Okay, and then in the middle clouds, you'll have your altostratus and your altocumulus. Again, cumulus clouds that are in the strato or the alto, these are typically very small cumulus clouds that do not grow, do not become much of any kind of weather or precipitation. Okay, and then high clouds, you have your cirrostratus, your cirrocumulus, and your cirrus clouds. So you notice that pretty much all your high clouds are starting with the cirro, okay, or cirrostratus, cirrocumulus, and the cirrus clouds, sorry. Cirrus clouds are like the real wispy ones, okay? When you're this high up in the atmosphere, these are all ice crystals, okay? So there's not a lot of precipitation that are ever going to come from these because they're frozen. They're so high up, it's so cold. Then you notice the middle clouds are going to start with the alto. Alto means middle, so altostratus and altocumulus. And then your low clouds are usually just have no kind of prefix. You have your stratus or your stratocumulus. Sometimes it starts with stratus. And then your nimbostratus typically have a lot of precipitation as well. So these are some of the clouds that you'll see. I want you guys to kind of start to look up in the sky and start to recognize and pinpoint what is what, okay? All right, so when it falls from the heavens, yes, we're talking about precipitation. There's lots of different types of precipitation. We have dew, okay, that basically is condensation from some of those water vapor molecules in the air. So in the morning, sometimes you see that dew forming on the leaves. You have a mist. Mist and fog can be typically the stratus clouds that come down to, Earth, and they're in the form, basically, it is a cloud that, is surrounding you. But a lot of times you might have a little bit of precipitation with that, kind of a mist. You have your rain, you have your hail, and hail formation, again, it's talked about in your unit, but basically you have this movement of, warm versus cold air masses, but basically they are taking these water molecules and they're starting to drop, but then this air mass brings it back up to where it's cold and it starts to freeze. And then it drops, and then all of a sudden the air mass catches it and takes it back up, and it gains more water molecules but freezes as it gets higher up in that cloud, and then it drops. And soon it'll be either too heavy or that air mass will not catch it again, and it starts to fall in the form of hail. Now, of course, if it keeps going in this cycle, that hail particle gets big, huge, to the point where it can be like golf ball size and baseball size and do some really big damage, okay? And then snow, obviously, when it's cold, that precipitation is going to freeze before it hits the ground, which is snow, which we've all seen so much, right? Okay, so those are kind of the forms of precipitation. And then the last thing I just want to talk to you guys about real briefly is just the crazy storms that come about with our weather, different cloud systems. Obviously, you can have thunderstorms that typically with the cumulonimbus clouds, those will form, and you have all these electrical currents that are going on within these electrical particles. That's what can cause those lightning storms. They're really kind of cool. And then you have tornado clouds that form from, this circular motion that starts to occur kind of on the bottom side of a cloud that starts with a funnel cloud. And as that keeps going, and that funnel cloud is circling in massive, crazy speeds of wind, if it touches the ground, that is a tornado. Okay, so obviously that picture there. And then you have kind of hurricane-type storms. Again, a circular motion of these of the storm cloud that can gain speed and gain energy, and ultimately, can be very destructive as well. So I'm not going to go into many details about those. They're pretty cool. If you guys are ever interested, feel free to do some research on some of those. I just think it's pretty cool to know a little bit about the storms and how they come about, and what makes them so dangerous. So there you have crazy storms. Okay, so enough about our Earth, some of the cool things. Of course, next time I'll have more to share with you guys, but there is just a little bit for you on the water of our Earth. All right, peace out.